No. See ma. So this is the given ma. The RMS speed of hydrogen is √7 times that of the RMS speed of nitrogen. Okay ma? Then if T is the temperature of gases, then what is the relation between the temperature of hydrogen gas and temperature of nitrogen gas? Okay. So therefore, according to the given data, what he gave ma? So RMS speed of hydrogen. So we will write V RMS of hydrogen is how many times bigger ma? It is √7 times of the RMS speed of nitrogen. This is what he gave, no? Okay ma? So then I want relation between temperatures. It means you have to use, so I think 6 equations of RMS velocity we have studied, no ma? So out of those 6 equations, you take any one equation where temperature is present. Okay? Then very easily you can get the relation. So which relation I will use? Okay ma? I can use square root of 3 kT divided by m0. I can take this relation, no? Okay? Now can you say what is the meaning of this equation? I can take root 3 kT by m0, or also I can take a square root of 3 RT by capital M also. Are you able to understand? So what is the meaning of this one? I can also use square root of 3 RT by capital M also, no ma? So what is the difference between this equation and this equation? This is here m0 represents mass of single molecule. Here capital M represents mass of 1 mole of molecules. So anything you can use. Okay, so every molecule will have same speed, no? Every molecule will have a speed √7 times when compared to the speed of nitrogen. So whether you take molar mass or single mass, anything is same. So I will take this one. Okay, so this is equals to √7 times of RMS velocity of nitrogen. So 3 kT divided by again m0. So this mass is for hydrogen, no? And this mass is for nitrogen. Clear, no? Clear? Similarly, here T means temperature of hydrogen, here T means temperature of nitrogen. Okay. Now see what are the terms which can get cancelled, ma? So 3k, 3k, √3k will get cancelled, no? Then I will square on both sides. Square on both sides. Okay. If I square on both sides, what I will get? I will get 3h divided by mh is equal to √7 and square will get cancelled, no? So 7 into Tn divided by mn. This is what I will get. Understood, no? Now what is the mass of hydrogen? Mass of single hydrogen molecule. So 2 atomic mass units. Clear, no? So therefore I will write here. So temperature of hydrogen divided by 2 is equals to 7 into temperature of nitrogen divided by, what is the mass of nitrogen molecule, ma? Nitrogen 28. Clear, no? So 7 1s are 7 4s are. So again 2 1s are 2 2s are. So therefore what I got the temperature of nitrogen is equals to 2 times the temperature of hydrogen. Okay. See if we have any such kind of answer. See now. Temperature of see whether our calculations are correct or not, ma. 7 4s are, 2 1s are, 2 2s are. So temperature of nitrogen is 2 times of temperature of hydrogen. Same answer I got. Okay. Let us check the options, ma. I think wrong options I have given. I think options I have given wrongly. Clear, ma? So you do one thing. So here you write down 1/2. Now it is correct, no? So temperature of hydrogen is half of temperature of nitrogen. So third option will be our answer. Okay? Make a note. Okay, ma? So next question is this one, ma. This was previous Neet question. So compressibility of the gas is less than unity at standard temperature and pressure. Therefore, what about the volume of this gas? Understood, no, ma? What is meant by compressibility factor? Already we have studied, no, ma? PV divided by nRT is equal to Z. Okay. So this is called as compressibility factor. Clear? So this value, it is less than 1. Then we have studied already that attraction forces are dominant. This is what we have studied, no, ma? Attractive forces are dominant. If attractive forces are dominant, then what happens to the volume of the gas? 1 molar volume will be less than 22.4 liters. Okay? At a standard temperature and pressure, 1 mole of any gas will occupy how much volume? 22.4 liters. But when attractive forces, when they are dominant, that volume will be less than 22.4 liters. So therefore, what is my answer? Option B. So Vm is less than 22.4 liter. Clear? Yeah. Okay. So this is the next question which is given. So van der Waals equation, okay, of state for a non-ideal gas. It means real gas. Non-ideal gas is nothing but real gas. The term that accounts for intermolecular forces is dash. So van der Waals equation is what? So P plus n square A by V square multiplied by V minus NB is equal to RT. This was the equation of van der Waals, no? Clear, no? And this is for n moles of a gas. For how many moles? For n moles of a gas. For 1 mole of gas, Chapandi, P plus A divided by V square multiplied by V minus B is equals to RT. This is the equation for how many moles? For 1 mole of a gas. Okay. So here we have two correction factors. One correction factor is present for pressure and one correction factor is present for volume also. So which correction factor is related to intermolecular forces? Which one is related to intermolecular forces? A by V square is related to intermolecular forces. Already we have studied, no? So in ideal gas, there will not be any intermolecular forces. But in real gas, definitely intermolecular forces will be present. Forces can be either attractive or repulsive also. But in most of the time, it is attractive only. Are you able to understand? And because of the attractive forces, the net pressure of the gas on the container reduces. Okay. So therefore, because of intermolecular forces, what is changing? Volume is not changing, pressure is changing. Okay. So therefore, this is the correction term which is related to that accounts for intermolecular forces. So this is our answer. Understood, Nama? So therefore, if you forget, make a note here. Okay. So due to intermolecular forces, what is affected? Pressure is affected. Pressure is affected. Okay. So therefore, we have to write a correction term for pressure. That is. So previous Neet question, ma. So see this question. So for 3 different gases, values of van der Waals constants A and B, they are given. So where you find A, ma? A you will find in the correction term of pressure. Clear, no? And where you will find B? In the correction term of volume. Clear, no? So these values are given. Then which is the correct order of liquefaction of gases? It means that which gas will liquefy more easily? That's the question he is asking. So by looking at this A and B values, we have to say which of these options is correct. Anybody? How? Very good. That's the point which we have studied, Dama. So in van der Waals equation, P plus n square A by V square multiplied by V minus NB is equal to RT. This was the equation we have written, Dama. So B is called correction in volume, no? B is called what? Correction in volume. Okay. So, and what is A called? A is directly proportional to attractive forces and it is directly proportional to liquefaction of gas. This is what we have studied, Noma. It means more the A value, more will be the ability of the gas to liquefy. Then what is the purpose of B here? B is not useful for us. Just to confuse you, he gave these B values. There is no relation of B on liquefaction of gas. Just you have to check which value is having highest liquefaction. Y2 is having highest liquefaction, no? Then followed by Z2, then followed by X2. So wherever you find this option, that is my answer. Okay? 4.1 is bigger than 2.2, 2.2 is bigger than 1.3. So which option? Option Y2, Z2, X2. This is my answer. Are you able to understand, ma? That's all. Wow. Okay. See, ma. So this is the given question, ma. Van der Waals equation for CH4 at a low pressure. Okay. So it means that he is considering real gases only, ma. If we mentioned something about pressure or volume, it means he is saying about real gases instead of ideal gases. And what is the equation of a real gas? Okay, ma. P plus n square A by V square multiplied by V minus NB is equal to RT for n moles of a gas. But I think he gave a question on 1 mole of a gas, no, ma. N is not mentioned. So P plus A by V square multiplied by V minus NB is equals to R into T. This is the relation. Okay. So which one is lower, ma? Here pressure is lower. Pressure is lower. It means that volume is bigger, no? So therefore I write volume is large. If volume is large, what you have to do? You have to remove the correction term of volume. Because volume is very big, no ma? So NB becomes very small. Are you able to understand? So whichever is bigger, so you remove the correction term of that particular parameter. Understood, no? Therefore, how can I write the equation? I will write P plus A by V square, okay ma, multiplied by V is equal to RT. Okay? Now just manipulate this one and see out of these forms which form you are going to get. So PV plus A by V is equals to RT. So anything which is matching, ma? PV, this one is matching, no? So that is our answer. Okay? So PV is equals to RT minus A by V. So this was also previous AIPMT question, ma. Okay?